Good. Okay. So people have been having issues with it's so nice to see so many people here. This quiz, I should just make the quizzes harder and harder, right? Because then you show up. Um, just kidding. Yeah, I'm just kidding. I'm trying something new today. I'm going to live. So people were complaining about the fact that they couldn't see the that Blackboard Collaborate Ultra was downgrading the image so much that they couldn't see. So today, what I'm going to do is I'm going to dual stream um the let me see if I can say this properly because I can't seem to get the words out of my mouth. I'm going to dual stream to Twitch. So if you want to watch the video, if you want to watch I'm only dual streaming um the quiz review. So I'm dual streaming the quiz review both to Blackboard Collaborate Ultra and Twitch. You can ask questions if you want to in Twitch, but remember those questions are public. If you want to protect your privacy, please ask questions here in this chat. This is the preferred chat in Blackboard Collaborate Ultra, but you can ask them on Twitch. This seems to work a little better for a lot of people because they can watch them on different devices. So people have told me that they're watching the Twitch on their PlayStation, which, okay. Let's go for it. So I'm going to try this and I'm going to be very careful about questions and stuff like that. So if you ask me an audio question, right, you can still raise your hand and ask me an audio question. Because I'm wearing headphones and because I don't rebroadcast that stuff, your voice will not be recorded or broadcast on Twitch, because I'm not, at least I'm pretty sure it won't be, unless this thing is doing something absolutely nuts. And I'm fairly decent at Twitch. I'm not the guru or anything. Well, I am in the math department, but that's not saying much. But so what I'm trying to do is I'm trying to protect your privacy just like I do during the lectures I'll repeat your question. I won't say your name. I won't say any names on the thing. And I'm going to try to be very careful with the information I share. So we're giving Twitch a try, for the quiz review only. Obviously the group work will still be on this or on Discord. Are there any questions about that? So if you guys want to watch it in full 1080p, you can do so on Twitch. I will be using Blackboard Collaborate Ultra for the polls. You can ask questions on Twitch chat, but remember those are public, or you can ask questions in here. So 1 to 5, how do we feel about the new kind of format trying to make this work? So 2, 3, 4, 5. Okay, no, so for the group work, we're still going to be in Blackboard Collaborate Ultra. We will still be screen sharing in Blackboard Collaborate Ultra. We're still using Blackboard Collaborate Ultra. The only thing that I'm doing is I'm broadcasting the quiz review over Twitch. Okay, that's the only change. So you can have Blackboard Collaborate Ultra open, but you can open a Twitch window and see the full 1080p of what I'm writing on the board, because Blackboard Collaborate Ultra apparently will not support high resolution, but Twitch will. Okay, so you can, if you're fine with it being a little blurry, you can watch it here. If you want a nice crisp picture, you can watch it on Twitch. And I am trying to accommodate that. Now, if that doesn't work, we'll figure something else out. But this is what I'm trying today. That's kind of the plan. So you can watch it on Twitch. You can ask questions on Twitch, but again, those are public. I'll be doing polls and everything on Blackboard Collaborate Ultra for this thing. Yes, you can watch you can watch it in both platforms at the same time. That's what I'm trying. Now, whether or not my bandwidth up will do it is another issue, but I think it will. Are there any other questions? And again, if you raise your hand, I won't call on you as I won't point to you, but I'll be like person with the question raised, please ask your question. And again, the audio that you speak will not be broadcast over Twitch. It only goes to my headset. Yeah, and you'll have to mute your mic in one of the platforms because there'll be a mic delay. Yes, so the recording will still be on Twitch. Remember that Twitch deletes recordings. I will still edit, cut, and do the video on YouTube. So I'm still doing the YouTube thing after. There is a time delay, and Twitch, I don't think supports live closed captioning. Of course, YouTube supports it later. So if someone has an SAS complaint, you can make one. I'll get in trouble or I'll have to modify it, and that's okay. But this is the new solution that I've come up with. If it doesn't work, it doesn't work, and we will do something else. Okay. So yes, so you can watch me here, but again, it's not 1080p, whereas Twitch is. Any other questions before we begin? Okay, so again, it's not the lecture, it's not the activity. So the activity will be on Blackboard Collaborate Ultra only after the quiz review. I'm not sure how much time will be left because I'm going on and on. But the quiz review will be broadcast to both platforms. We'll see how this works. If it doesn't work, we'll figure something else out. But I think this will work. Okay, so this quiz was a little bit of a brutal one. It was rather hard, and it's also the first time you're seeing these things. It's the first time you're being asked how to write these things. This is a really important quiz. I'm going to try to cut the videos early, and I'm actually going to go over a little bit of how these are graded. So let's just jump into it. The first thing I want you to note is the instructions. Now, these instructions, I lifted these off I didn't lift them off the test. I wrote the test last semester, so I literally took these instructions and put them on the test last semester and the previous semester. These have been the questions for a few semesters. They will probably be the instructions this semester. So I try to make the quizzes as close as possible to the test. But let me show you what they be, right? So if in particular, don't write D&E if there's an infinite limit. If a limit doesn't exist, you need to explain why. Show sufficient work to communicate your process to a peer who does not quite understand the problem, stating any theorems or special limits used. The big thing here is if you use two cops to do something, you better say it. If you use that special limit, our special limit we had, right? We had the special limit 1, which was the limit as x goes to 0 of sine of x over x equals 1. If you use this limit, this needs to appear on your paper. You don't need it in any of these. But if you do use it, this needs to appear on your paper somewhere on your test. And you need to say that you've used it. So, that could mean like writing, what I would recommend doing is just writing special limit 1 on the first page in like the upper right-hand corner as I have here. And then if you need it, just put SL1 above the equal sign. But you don't need it for this quiz, but that's what that means. If you need if you use nothing else matters or one of the direct substitution theorems, I would cite it. We've had arguments about this in the test. What do you need to say? Do you need to read every limit law? I'll get into that exactly how it's graded. Also note that the answer key here is super pedantic. I have done every little possible thing that could be done in communication. And I'll go into the rubric and how that works in just a moment. But note that I've done more than you need to. So the standard is a peer that doesn't quite understand. So if you were explaining this problem to someone who was, say, in business calculus, and they didn't quite understand the problem, okay? That's the idea, is that someone who didn't quite understand could follow the logic and understand why the thing you are stating is the thing that you're stating. Okay. let's get into that. This first one. Now, as you can see, I've done this, totally not necessary, but you could get communication points for it. And I'll go through this. The top goes to 0, the bottom goes to 0. I need to do more work, right? 0 over 0 is one of those forms that I can't determine. So I say that's equal. Now I'm going to factor it. And when I factor it, I wind up with something that is 6 over 5. That's a direct substitution. 3 plus 3 over 3 plus 2 is 6 over 5. Now, just the computation part, not the communication part, just the computation. 1 to 5, how do we feel about that? So let's see. Polling, multiple choice. I so need a TA for these. 1A. So in Blackboard Collaborate Ultra, I've started a poll. 1 to 5, how do you feel just about the computation? Not what you need to write, just how to get from the first part to the second part. All right. So we feel pretty comfortable about the web assign that I need to factor in all of these things. Now, how do I communicate? What's here? Now, this is the way that they were graded, and I don't know if this will be great, if the rubric is going to look just like this this year. And if it doesn't, what I'm going to do is I'm going over the rubric probably today or tomorrow with the with another instructor who is now the coordinator. So I'm going to go over this rubric and make sure that it's still going to be the same-ish as it was last year. Okay, I'm not showing the name. That's good. Let's move this over. Okay, so let me share my screen. Okay. This is what the rubrics tend to look like. Okay? Now, this person here, I've got a computation, and there may be one or two of these different things, ways to do these, okay? But as you'll see, there's kind of a, there's computation points, and then there's communication points. And then there's negatives on here. This is out of 3. And normally the problems are either out of 5. And if they're out of 5, it's like 3 for computation and 2 for communication. Or it can be 2.5 and 2.5 or whatever. The point is that this is how they're set up. Okay? The computation part is like half the problem, maybe 2/3 of the problem. Somewhere between there. But the idea is half of it's getting to the right answer. And half of it is communicating how you got that answer. So if you do nothing, if you do no work, you get no points. If you put 6 over 5 on this piece of paper, you would get a 0 for the problem. We don't give credit for pulling numbers out of your behind. Even if they're the correct numbers, we don't give you credit for that. You draw me a little picture and pull the number out of your behind, that's a different issue. But if you give me a number just with no explanation, you get nothing. Now, if I do this, the computation part, here I factored. I wound up with something that was like 3 plus 3 over 3 plus 2, and then I arrived at 6 over 5. Now, if I had written this step and this step, I would still get this. If I had written this, if I had written this, so if I had written this and this, I would have gotten full points for the computation, right? Because once you factor it and then come up with 6.5, 6 over 5, it's obvious that you did the stuff in the middle correctly. That's the computation credit, right? You've demonstrated that you understand how to get to the answer by at least, doing a little bit of stuff in the middle. All right. Now, communication. And this is a little bit harder to understand. The standard here is sufficient to show your work. Now, I've shown more than is needed, but let me show you what these look like. I click over here, right here, and notice that this thing is capped. Now, it's kind of like the notes in the sense that you just need to accumulate the number of communication points you need. You don't hit everything, right? And that's natural, right? There are multiple ways to communicate what's going on. I could have words down here. I could say, oh, I factored and then did this. And that's communication, right? Because someone who didn't quite understand the problem could then follow your process and go, oh, that's how you did it. So, you could have, and again, this is not complete yet because I haven't gone through all of them and added every little way that you could have communicated. But, I showed this step from cancel before the substitution, right? So that's this step right here. I showed the factoring. I'm sorry, that's this step right here. So I need to add that I did 0 over 0 somewhere. Add rubric. So let's see. Here, I'm going to give you plus 0.5 if you did the arrows with 0 over 0. Top to 0, bottom to 0. Oops. That sort of thing. So I could call that a 0.5 thing, right? There's all sorts of things you can do to communicate. And you don't need to do everything. You just need to accumulate 1.5 for right now. I don't know if this will become a 2-1 or something like that. And then, right, so right here, I showed this step. That would have been 1 point. I did a justification, like I used the direct substitution theorem. So I wrote ds above my equal sign. That would have been a point. I showed this step. I did, this would probably be another one. I actually said rat. That'll probably be a 0.5 as well. I did this step, which showed exactly what happened to the 3, right? The 3 went in here. So from here to here, it showed that the 3 went in somewhere. So that's good communication. All of those things are great communication. And you just acquire enough communication points, right? I could have gotten full credit if I left out this step, left out the dots and dots, and did this step, that ds, and this. Okay. So how do we feel about what's expected for communication? That there are 1,000 ways to do it. And all of those ways will be reflected in the rubric. And you just need to do some of it. So how do we feel about kind of how this thing gets graded? One to 5. And I know I'm eating a lot of time talking about this, but it's one of those things that makes people nervous. And I'm trying to assuage your nervousness. I'm trying to show you that there are 1,000 ways to do these things. You just have to do one of them. You just have to kind of accumulate enough. And I don't want you to be going in there. We're still talking about 1A, right? Okay. And I don't want you going in there worried about how to communicate. Okay? The point is do some stuff that could show to someone else how to do it, right? So I could have left off a lot of this stuff and still accumulated enough points. Okay? Right? So like 0.5, actually saying the more work, stuff like that. But you're capped, right? You can't get more communication points. All right. And I just want to make sure that you're not nervous about that going in, because I want you stressed about understanding the math and communicating it, but I don't want you stressed about the grading. All right. I want you stressed about the right things. I want you stressed about knowing how to find things and knowing how to explain it. All right. Those are the things that we're interested in. Can you do it? And can you explain how to do it to someone else? And those are the things I want you thinking about. How can I communicate? I don't want you thinking about the rubric going, oh, did I get enough communication points? If you communicated, you will get all the communication points. If you didn't get all the communication points and you feel you communicated, we'll talk about it. Because if you feel that you communicated and then explain to me what you did, often I'll be like, yeah, I get it. especially if you do something a little non-standard. Now, there's one minus here that you need to be aware of, and that's if you're missing a limit sign. So if this person here, before I subbed in, if I had not had that limit sign, that would have been minus 0.5. Okay? Now, the reason is because you said that two things across an equal sign that are equal, you've said that these two things are equal when they're not, right? The limit as x goes to 3 of this thing is a number. It's 6/5. X plus 3 over x plus 2 is not a number. It's an expression. Okay? So you must keep these limit signs in here. And you must have them everywhere because you will get docked half a point if they're missing. On the test, often you get docked a full point. Now, there is a way to do this with arrows only, okay? But I wouldn't do that because if you do it with arrows only, you're actually tend to run into other problems. So if you wrote arrows here and then the limit, it's kind of wrong. If you wrote here like an arrow and then this expression and then an arrow and then this expression and then an arrow with ds on top and then this expression equals this expression, you're actually correct as long as you write as x goes to 3 on the top, right? So I actually can do this in arrow notation, and that would look something like this. So I would do, this is the first statement. Right, and then I do the same thing I did before, which is kind of 0/0. More work. Mock work. And then I would write this arrow. Now, the only way I can get away with arrow notation here is if I write as x goes to 3. And I have to write that somewhere. Because now I'm saying, with an arrow notation, I'm now saying, okay, as x goes to 3, I wind up with x plus 3. Oops. All right. And I can continue this as x goes to 3 bit here. Because what I'm doing is I'm saying as x goes to 3, this goes to this. And I really shouldn't have the limit sign there if I'm doing it this way. So as x goes to 3, this goes to this, goes to this, goes to 3 plus 3 over 3 plus 2, which equals, and that's an important difference, right? The equals there, this is still evaluating a limit. 6/5. So you can get away with it. I do not recommend it, but you can do it. Okay? And people are always asking, how can I do it with the arrows? So I'll show you how. But again, I don't recommend it. I recommend that you stick to this method here with the equal sign, writing the limits every time. One trick to do is just to leave space. By the way, why don't I need a limit here? Anyone want to answer that? Why is there no limit there? Right, because here I substituted. I stuck in that once I stick the number in, there's no longer a limit. I've evaluated the limit using the theorem. Okay. So there are a number of ways to communicate. So the takeaways. The takeaways are this. There are a number of ways to communicate, and the limit signs, please put your limit signs where you need them. Are there any questions? And again, this is a source of anxiety for you. No one has ever asked you to do this in a math class unless you went to some private school or some elite gifted program, in which case, you're probably breezing through the course anyway. But this is something new. You're being asked to communicate on paper, and that's new. And I'm not saying it's not new, and it's going to cause anxiety. I'm trying to assuage your anxiety as much as I can about this. It is a deal, but it's not the biggest deal in the world. Once you once you start communicating, it'll become natural to you. Okay. So I've spent 30 minutes so far, and we're only through the first part of the first question. Great. Okay. The second one, and then there's an argument about this. But let's talk about the second one. Okay. For the second one, what I'm going to do is I'm going to look at the top. It goes to 6 plus. Now, the trick here is that -2 times 1 left. Right? I've multiplied I've multiplied 1 left by -1. I did this wrong, didn't I? So the way you multiply right here. This one. I multiply by -1. Right here. I multiply by -1 here. So this is right. That's a 3. And now we're going to subtract a number that's slightly larger than 2. We're going to slightly smaller than 6. Okay, that's a 3. That's a 3. So that's 6, right? It's slightly smaller than 6. So subtract my number that's slightly bigger than 2. Right, so I'm going to the top 1 6 times. Yeah, that's 6. So I'm going to 6 times. Right, so what is that? So anyway, I think 8. I'm subtracting something that's just to the left of 2. No, I was doing it right before, and now I've confused myself. I'm sorry, guys. It was correct before. I'm sorry. I'm subtracting by something just to the left of 2. Okay? I did it right before, and that's going to leave me with 6 right. All right. And of course, what would really be embarrassing if I messed it up again. So anyone want to take bets on that?
Well, it's a little too early. I'd say Thursday would be good. I'll know by then. Is that all right?
Okay. So I'm subtracting by something that is slightly smaller than 2. So when I do this, and I'm sorry for messing it up, it's one of those mornings. So I take 8, and I've got 2 left that I'm subtracting by. So here's 6, but I'm just to the left of 6. It actually doesn't affect the answer at all because 6 minus would have been the same as 6 plus, positive. I really screwed up when I did that. All right, so I wind up with 6 plus, something slightly to the right of 6. Okay. Now, on the bottom, this is the more important one. I've got 1 minus plus 2 minus. That's something slightly to the left of 3. So I've got 3 minus 3. So I'm at the left of 3, and I wind up to the left of 0. And the bottom one's actually the important one. So how do we feel about that bottom one, 1 to 5? You know, when the professor has a problem with the thing in the morning, it really, just destroys the morale, doesn't it? So how do we feel about the bottom going to 0 left? Okay, so I have 3. I'm to the left of 3. So the question is that you're having difficulty with the problem that if I start at 3 left and then subtract 3, I wind up left of 0. The reason why is because I subtracted from a 3 whole. So if I'm like it, think about 2.9. If I was at 2.999, and then I subtracted 3, where would I be? I'd be at negative 0.0 0, 0, 1. Up here, if I wanted to do the top again, let me change the color here. If I wanted to do the top with an actual number, I would do 8 minus 2 times something just to the left would be 0.9999, which is approximately, who cares, 8 minus, right? This is going to be something that's slightly smaller than 2. 1.9999. The exact number doesn't matter. Which is going to be approximately something like 6.0001. Exact number doesn't matter. I don't care if it's 0.81 squared. I don't care what the exact number is. The point is that it's about that. Okay. Well, okay, so there's the question. You actually came up with the answer. The big key is to know that the key to this problem is this. This is the really important thing. All right, and it doesn't matter if you have 6 left, as long as you know that something positive over 0 minus is something positive. And if you have trouble with these things, I recommend doing this. Drawing out the number line or picking a number that's just to the right. Okay? Either way works. Okay, so now that our brain is working again, let me ask again. 1 to 5, how do we feel about this problem? Now that the brain is working, how do we feel about this? So this is the infinitesimal trick. And by the way, if we graph it, we can actually see what's going on here, correct? We're going down here. As we approach 1, which is about right here, you can see that this is shooting down to negative infinity as we go to 1 from the left. And again, trick. Now, let me go back to this. If you get stuck, put in a number. So, and I should say that as scratch. Right, because it's not actually equal to that. The infinitesimal trick is this, but if you want to check your trick, go ahead and just put in a number. So, a theorem. So, this is one of those things that some, purist people, instructors, frown upon, right? Because they're like, oh, you can't do that. It's not formally correct. There's no theorem. Well, you need, graduate school in order to understand this forcing trick that the guy's using, right? No. Okay. You don't, so it's not really a theorem. It's a trick. You're using kind of a reasoning intuition bit about it. And that's what you kind of have to write down, is that you're using a trick. Now, again, some people are like, no, you can't do that. Yeah, you can. People that are enamored with French analysis says you can't do this, but you can use this. So you see this, I kind of just wrote equal with a little asterisk, right? So that's kind of what you're doing, right? It's not really equal. You're using kind of an infinitesimal. Technically, what you're doing is you're expanding the real number line to include things. These are called either surreals or hyperreals, depending on which book you're reading. But just like you can tag infinity onto either end of the number line, you're doing the kind of the same thing. You're saying that there is a number just to the right of 6, even though on the real line there is no such number. You're expanding it and saying, well, suppose 6 plus did exist, and you can do this logically. It's just you have to be a little bit careful. So that's what you're doing. And it should be noted that this is how calculus was originally thought of. And then, the French came along and lost the Franco-Prussian War and then said, let's invent French analysis and, make it all formal in a way that's kind of silly. Yeah, so if you're pro-French, the French are kind of the butt of all my jokes. So, and I think they deserve it for inflicting French analysis on it. But okay. All right, this one here. this one here, the important thing is I'm going to infinity. So I can use nothing else matters on this, right? This is an infinity on a rational function. Nothing else matters.
And nothing else matters.
So the only terms I pull off here are the ones with the square because that's the highest term in both.
And nothing else matters.
So I wind up with the limit as y goes to infinity of negative 2y squared over y squared. I pull all of the coefficients, including the negative, right off there.
And nothing else matters.
I cancel the y square. I wind up with this limit y goes to infinity of negative 2. Now, I have to keep that limit sign there. That's a little weird because I haven't actually evaluated the limit yet. I know it's a constant now, but this is constant as a function, not constant as a number yet. And I'll get into this right after test 1. So on the first lecture back, this right here. So and as I said, I'll get into this when we get back after test 1. No, so you can just write NEM. NEM is sufficient, right? This is extra communication. And the reason why I wrote this was to make sure that you don't make the mistake, right? Because NEM only works with things going to infinity or negative infinity. And that's important, okay? I have to be going. NEM stands for nothing else matters.
And nothing else matters.
The point is that the only thing that matters is the thing with the highest exponent.
No, nothing else matters.
How do we feel about that one? 1 to 5. I lost my Twitch chat. There it is. And the theorem, again, that you should put down to answer the question in Twitch chat is nothing else matters for that. The 1. Someone's saying they're confused about the 1. I think you mean this one here, because when I canceled y squared over y squared, that became 1 over 1. Because I'm nowhere near 0, I can do that. That's where those 1s came from. When I canceled y squared and y squared, they became 1 over 1, which is fine. Again, the smartest people ask the dumbest questions. That's how they got smart. And I will never criticize you for having a brain fart. I have them all the time. As you can see, I had them before. I had one before. I was like, wait, am I doing this right? Yes, I am. I keep telling myself that. Someone wrote, oh man, I'm going to be a genius someday. Yep, I keep telling myself that. Okay. All right. Part D. This is a changeup problem. Okay. What do I mean by changeup? You take 0, you plug in 2. Notice that this is in the domain. Negative 1 is actually in the domain here, right? I mean, if you really want to get this nice and pretty, if you want more things, right? You do negative 1 plus 1 over negative 1 squared plus 1. And this becomes 0 over 1 plus 1, which equals 0 over 2, which equals 0. Okay? That's the point. It went to 0 over 2. Well, 0 over 2 is fine. Yes, ds rat will actually give you a little bit more credit, right? That's ds over a rational function. ds rat is actually the better thing to say. Oops. All right. And this is a soft, right? This is a changeup. You could use quotient law to break this up. That is a perfectly valid way to do this. There are a couple ways to do this. But the point is that sometimes, every once in a while, they throw one of these at you, which are asking you to overthink. They want you to get completely unconfident, and they want you to just try to plug in weird stuff. So how do we feel about that 1 to 5? It's just throwing it in. Okay. Yeah, so you can plug it in because the denominator is defined. That's a perfectly good way to put this. If the denominator was 0, this wouldn't work. All right. The distribution substitution method. I think what you're asking is that you can't factor x squared plus 1. It's irreducible. Well, I mean, you can, but they come out to be complex numbers. So it's -1, but it's -1 squared, right? -1 squared is +1. I take -1, I multiply it by -1, I wind up with +1. So this is actually just 1 plus 1, which, you know, it's an easy mistake to make. All right. Okay. Moving on to the next one. Part E. I talked about this last time in that difference of squares. Now, there are a couple ways to do this. You can also do this by multiplying the conjugate, and you'll wind up with the same answer. But if you wind up with something like the square root of x minus the square root of t, it's sometimes easier. Now, multiply the conjugate is a trick you have to use in a bunch of cases. But if you wind up with something that looks like this, you can actually use the difference of squares on the bottom. Now, it's not obvious right away, but you can do it. You can also conjugate it. That's legal. Okay, multiply by the conjugate. So let's start with the thing. And notice here that x is fixed. Now, the square root of x minus the square root of x. If I sub in x for t, right, I wind up with the square root of x minus the square root of x, which is 0. If I sub in x on the bottom, I wind up with x minus x equals 0. X being fixed means that x is a number. It's not moving with the limit. X is defined before the rest of the statement. Okay, it's not a moving thing. It's just some real number. It should be some real number not equal to 0, but it's close enough. Because if it's 0, then the limit from the left probably doesn't equal the limit from the right. I'd have to work it out. Anyway, and I wind up here, if I factor the bottom using difference of squares, if I notice that the x minus t equals the square root of x squared minus the square root of t squared. So this thing actually factors. So I factor it, I cancel that, and I wind up with 1 over the square root of x plus the square root of t. Now, the top is going to go to 1, and the bottom is going to go to 2 root x. So I directly sub in, and I wind up with 1 over 2 root x as my answer. And then if you have to rationalize, this is how you'd rationalize. But don't rationalize. Don't do this. Please don't do it, because you can only lose points if you rationalize. How do we feel about that 1 to 5? How'd I get 2 root x? So if I directly sub in here, I wind up with 1 over the square root of x plus the square root of x, which equals 1 over 2 times root x. Okay. And there is no t, right? I'm taking t. If x was a number, if x was 1, I'd take 1 and sub it in for where I saw t. All right, now how do we feel about that? 1 to 5 here. So let's see, part E. 1, oops, 2, 3, 4, 5. I wish there was a way I could write a script to do this for me, right? Where I could just do poll. Will there be a question like this on the exam? Definitely there will be something involving radicals on the exam. Definitely there will be a limit where you're going to something that's constant. I can guarantee those things. Or at least as much as I can, in the sense that they've had one every. So if past exams are indicative of the next exam, of this year's exams, yes, there will be one on there. Because there usually is. Yes, you will need to write theorems. Are exams multiple choice? Absolutely not. This year we're adding a few true-false questions, I think. But it's not most of it. No, you will not get the test ahead of time. You will get study guides though. Yeah, so I put up, I'll talk about that stuff in a moment about the WebAssigns. So there's some really good questions going on about the test and everything, and I will talk about that. Okay, so does this extra step, people are asking the question, they're lost from this. Did adding this extra step clarify issues for you? And this is what I mean by communication, right? There are people that didn't understand, when I just skipped this and went to 2 square root x, there are people that missed this direct substitution step. So if I add that in, I get a little bit more communication. All right. Okay, now again, way over the top with detail. Okay? This is way over the top with detail. Way too much detail for this quiz, for this proof. Okay? I put in everything you could think of. I basically threw the kitchen sink. But I would do this. Notice that I wrote an introduction. If nothing else, write an introduction. You see this word prove? If you see the word prove or show, or I think show is the thing that they, or demonstrate or explain why. If you see those words, it looks like proof. Okay? Now, this is my introduction here in green. What did I do? I said what I wanted to do, I restated the problem, and then I said how I was going to do it. Okay? Now, notice, if I messed up and I didn't mention 2 cops down here, that will be a requirement that you mention 2 cops. It will be in the rubric. But notice, if I forgot to do it here, I did it here, so I get the points. If I had just said strategy 2 cops, I would have gotten points for that. And that's one of the reasons why you want to write introductions, right? You memorize how to do this type of problem, you rewrite the problem in your own words, and then you say what your strategy is. Because if you run out of time, you'll get points for that. Now, normally on a test, let me move over here. Normally on a test, you would get, there'll probably be a state the theorem on the top of the test on the first page, and then yada, 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 come down. You wind up with a question like this one here. If where you needed the theorem. If that's the case, I wouldn't rewrite the theorem. Okay. I just, refer back to my notes. But since you didn't have it here, I would actually write the theorem. Oh, shoot. I put a for all in there, didn't I? Now, this is not necessary. A lot of times, if I really know a proof, all I will do is this. I will just draw the picture. Okay? Because that reminds me what I need to set up. Okay? And you get points for these things, right? If you totally botched the proof, but you knew you had to use two cops, and you kind of said what it was, and you don't need to rewrite the whole thing, especially if we've already written it. So you would say, I wrote it in question 1B was the thing, right? I mean, for time immemorial, the three things that have shown up on the first test. There are other little things that we could put on it, but from time immemorial, I will pick a random semester here to pull a test up here. So let's pick spring of 2019. Let me compile it real fast. Let me make sure I don't put in the actual thing. So since time immemorial, these are the things that show up on the test, right? Your first page is something like this. Okay? This particular one is spring of 2019. State the squeeze theorem, otherwise known as two cops and a junk. Define continuity. Given a function, define f prime using limits. Okay? Other things that can appear here. Last semester, it was state the squeeze theorem or state two cops, state the intermediate value theorem, state the definition of the derivative. This is always the things that show up. There's like 4 things that could show up on the first page. We're going to ask 3 of them. So at some point, you probably already have written this down. All right. But if you haven't, go ahead and write it again. Okay. So I need to do 2 things, right? I need to show that for all x right near a, top of x is greater than or equal to f of x is greater than or equal to bot of x. And I need to show that as top of x goes to L and bot of x goes to L, x goes to A. I'm sorry, that these 2 things both go to L as x goes to A plus. Those are the 2 things I need if I'm going to use 2 comps. So, what am I going to do? I'm going to start here, right? I'm going to say, okay, -1 is less than or equal to sine of 1 over x is less than or equal to 1. Okay? Now, totally optional to say this, but if you miss something else, you'll get a couple points for that. That'll be part of the rubric. And then what I do is I multiply through by x cubed, noting that x is positive. Right? X cubed is positive when x is greater than 0. So when I multiply through by a positive number, I don't flip my inequalities. Right? If I multiply through by a negative number, I have to flip all the inequalities. But if I'm multiplying through by a positive number, they just stay the same. All right, so then I say what top and bot are. Top is x cubed, bot is negative x cubed. So top is greater than or equal to f, greater than or equal to bot, right near a, for any positive a. So for any positive number, which is right near a. Maybe I'll write right near 0 here. So my first condition is met. The second thing, I show that I've met my second condition. Second condition met. Therefore, I can apply the theorem, and the limit as x goes to 0 plus x cubed, sine of x of 1 over half equals 0. And then I write the neener quad erat demonstratum there, or QED. Okay. All right. Are there any questions about this? This is a long one. Yes, you lack QED. This is a mathematics way of saying neener, neener. It's a mathematics way of saying neener, neener. I know what I'm doing. I know what I'm doing. If you must, there's a Wikipedia article you can go to. There it is. QED. You can look it up. What does it mean? You can read about the whole history of QED. Okay. There is, but I the point is that, what's the point? The big idea. What is the takeaway? Write your strategy. Write your theorem. Show you meet the conditions of the theorem. Now, again, this was like super pedantic. I did every little thing that you could say here. You did not need to do this, okay? You did not need to go into all this detail. All right? But you did need to show what you were doing. And note the ratio of words. I'm going to put that down here. There must be words. Notice here what I've got here. I've got about a 2-word to 1 symbol ratio. All right? It's a little bit high. A 1-to-1 ratio is kind of the minimum. Okay? I should have as many words as I have symbols. Especially in the strategy. In the strategy, it should actually be a 2-to-1. I actually have a bit too many symbols in this thing. But the point is, right, this strategy should say multiply through by x cubed or something like that, okay? But the point is that there need to be actual words. You can't just throw a bunch of math symbols before that. This is an argument. So what is a proof? It's not, this whole high school thing. It's a series of steps that justify line by line. No, it's an argument. Sound, yes, but it's an argument. It's a discussion. You're making, it's a 5-paragraph essay in English class. You are trying to convince your reader that what you have is true. Okay? What you're going to do it, say what you did. All right. Now, how do we feel about that? 1 to 5. Okay, it's a max. All right. All right, we will work on it. People have been asking for videos. Maybe if I have a moment, I will make another one. I don't know if I have one. I did have some older ones. I'll see what I've got. But the point is, it's an argument. And you need to do this. Okay, one thing you found memorable. Are there any questions? I've eaten up the entire class time going over a quiz. Now, it's an important quiz, but I've eaten up the entire class time. Okay. All right, everyone needs to make sure that you're in, okay, I will look at there may be a YouTube video that was done. Yes, someone has a question on E. All right. Yes, so go ahead, ask your question about E. So on E, you multiply by the conjugate. That is a legitimate way to do it. So you can also multiply by the conjugate, and I will put that on the thing. You could also multiply by conjugate. Okay. Let me talk real fast, and then we need to split up in groups for a whole... Oh, crap. There's only 5 minutes left. I'm so sorry. Okay. Well, I guess there won't be a group discussion. We'll just end it rather quickly. So let me talk about what problem set 3 looks like. And you'll have to do it. You can do it in groups or on your own. I'm sorry for taking up the entire time, but it was an important quiz. So I think that at the margin, you probably got a lot out of it. Let me just talk about the problem set then, and then... let me talk about the problem set real fast. So there's 2 problem sets for this week. There's problem set 3, and then there's a problem set 3 chaser. So this is the problem set that people usually don't like, this problem set, in the sense that it sometimes takes a little too long to do. So I was hoping to cut it down. So what I did was I cut it down to kind of the bare essentials. It's a standard 30-bit thing problem set. If you have questions about this, please talk with group members, talk about things. This thing right here about using the special limit to solve problems. And then this bit right here about the context of the limit. Those are really important. Okay. So as I said, this problem set used to be longer. I've chopped it down to make it about an hour thing. And we were supposed to do it in class, but obviously with Labor Day and the fact that I went longer at a quiz, because the quiz should have probably been broken up into 2 quizzes, it didn't happen. So please do this on your own. There's also a chaser online. So this problem set is due as normal. You can do it in groups. It is due on Thursday at midnight, like a normal problem set. The second part of this problem set, the stuff I cut, okay, is extra credit. So this is the problem set 3 extra credit chaser. It is due on Sunday. You have to turn, you may work in groups, but everyone who does this has to turn in their own. And it's worth 15 points of pure extra credit into your quiz grade. And the point of this is to get down here and you'll actually prove that the derivative of sine is cosine. And this is actually really good because it starts you thinking about the stuff that we're going to do next week, which is the stuff about the definition of the derivative. And it kind of walks you through how to do this. Now, this proof is not on the test, but it gives you a practice on kind of writing a proof, writing introductions, which is good. And you create a new special limit, which is good. This one's special limit 2. Again, this stuff will not be on the test directly because we're not going to ask you to prove like the sign of the thing is. But this is really good practice on getting a hold of, on practice on writing introductions. And it's really good practice on dealing with this formula because this is the definition of the derivative. All right. Again, this particular thing is not on the test, but the idea playing with this is. Okay. All right. Make sure in the next 5 minutes that you jump into, that at some point you were logged into the, Blackboard Collaborate Ultra chat, because that's how I'll take attendance. So just everyone who was present in Blackboard Collaborate Ultra, since we didn't do groups today, sad, will get credit for being there. But the problem set, even though we didn't get it to it, is absolutely due on Thursday. Are there any other questions? Yes, so just make sure you were in Blackboard Collaborate Ultra at some point in the day. You don't have to say here, you don't have to do that. Blackboard Collaborate Ultra will log everybody's attendance, and then everyone will get credit for the attendance that showed up. All you have to do is log in. Any other questions? I'm sorry for just talking about the quiz and not getting you to the thing, but, you know, it was an important quiz, so I feel somewhat justified doing it. Okay, and did the Twitch thing work? So 1 to 5, how do we feel about the Twitch thing? Okay, so there's a question about how can I get more info on solving problems like E? I'm going to throw up some more. I put some more. So I posted let me mention this real fast before everybody leaves. Shoot, how do I get this thing to come up? Okay. So if you go on WebAssign, you will notice that I've actually posted all of the WebAssigns through test 1. And if you guys want some more practice, I may post a couple more. But all of the WebAssigns for test 1 are now posted. So you can see them all here. And on there is 2 extra credit assignments. There's Dr. H's prep for test 1. This is Dr. Hernandez from last semester. That's extra credit. There is a true-false quiz that is extra credit. Both of those are due next Friday. Remember, the combining functions is also extra credit due this Friday. The test is on Saturday, so on the 19th. These 2 right here are super important. There's some extra. I put some more of these infinity problems here in 6B. Notice there are 2 things due on this Sunday, but both of them are like, I think one of them's like 15 minutes and one of them's 20 minutes, maybe a little longer. So WebAssign is posted all the way through the test. If people want more practice, I might dig up some more practice problems, but they probably won't be for any credit. But if you want more practice on those, if you want more practice writing them, there will be a review posted as soon as we agree on what the review is. Any other questions? Crap. Right, so now it's going all over the place with OBS. Okay, so that's it for today. I went through I spent the whole time talking, and I hate doing that. If you do have more questions, is there any extra credit on the exam? Traditionally, the exam is out of 110 points, just like the quizzes. They're kind of 2 out of 20 built-in extra. There's usually 10 out of 100 built-in extra. So the test is usually out of 110 points. I don't know if we're doing that this year or if we're doing extra credit problems or nothing, but that's what usually happens. And I'll have more information about that when we finally agree on what the test should be. Again, I'm not the primary writer this semester. All I did was submit a bunch of problems, so I don't know what the end result will be. But traditionally, we have sat there and bickered like cats and dogs over the extra credit problems that this just seemed easier to just, put an extra 10 points in the problems. So the problem like E, there's stuff on, you can do the conjugation method. I'm actually going to add that to the key. But there should be some more limit problems in there, and I'll go see if I could hunt out a few more. But again, those will probably just be what they are, not extra credit. I think the other questions are all a bunch of here's. What is the best method, I think, to study? Study the quizzes. I cannot stress this enough. Study the quizzes. I've taken questions from previous semesters' exams show up on the quizzes. I will have a study guide with the list of the quiz questions to pay attention to. Don't worry about the definition of the limit. Don't worry about the definition of a function. I don't think I asked you the definition of the limit. That formal definition of a function bit from the first class is a short hazing ritual. It's an important definition, but it doesn't show up on the test. But there will be like a list of stuff and then memorize, and I cannot say this enough. If I put one of the theorems or the definitions on that study guide, memorize it. Know it cold. Picture all the statements, bulleted statements. Make it very clear what you mean. Know their definitions and theorems cold. So if I put it on the study guide, just know it. Study guide usually comes out the week before the exam. The weekend before the exam, so but we haven't even written the exam yet, so Sunday, Monday. That's the best I could tell you for the moment. everything just takes longer when everybody's meeting remotely, right? We can't just we can't just go to the Dunderbacks, order a bunch of beer, and sit there and crank out, the test, the answer key, the makeup test, the study guide, and the review sheets, right? We just can't do it because we're all remote, right? That's what usually happens is we go to Dunderbacks, we order a bunch of beer, we just crank them all out at once. We can't do it this semester. It just can't be done. Any other questions for me? Okay. Well, that's it then. And I will talk to everybody later. It's office hours now, isn't it? Okay. Bye.